Hello guys, welcome back to another video. In today's video I'm back with the part 7 video for building our house price predictor project. And in throughout last part videos I show you how can we collect data, and show you how can we prepare it, and then also I show you how can we fit into our data. And in today's video, what I want to show you is what we done when we fit our data, what looks like we did. And to show you that in the visualize way, I'm going to plot the data and with the linear regression line, and I'll show you that how can we do that. And I hope after you've seen this you're going to understand how the linear regression is work. And without further ado, let's get started. Okay guys, I'm back. As you can see here, we write many code, but in today's video what we want to do is we want to see how the area and the price data here are fits, how the straight line is fit in this data. And what we want to see is we want to see the straight line drawn in here based on the model here, the model we fit our data. So we are going to see that now. Okay, as you can see here, also we predict some random number. And now to do that, before we do that, as you can see, we want to draw a line, so that will be a linear regression. So which means the data will going to be the linear regression, so it will going to have a slope and a continuous. I think that's what I called it. So we are going to define that. So we are going to say m equal to we call our model linear regression. So we say linear regression dot curve, I think, and then 0. This will be our slope, and then our constant will be our b, and then we can say linear regression dot you know what, I forgot what it was. I've come back after a research for mistake. Okay, it's called I think intercept. Yeah, intercept. And then we successfully defined our slope and then continuous. Okay, now let's create our line. So through that we can say x line equal to we want to see numpy, so dot line space. And let me explain. Okay, what we did here is we just taken the slope of the model by using the curve in the first index, and also we take the intercept or continuous by using this intercept syntax. And now what we are going to do is here we are just creating some data to see the plot. So that's what I'm going to do here. So we want to create, let's say we want to see df area, area. This is what we want to see in the landscape, but just to see, we want to create from the minimum, and then let's increase this number by 1, because just the plot to be more, the line to be visible, also in the under. That's why I just use 1. And then from this number we want to create df df area dot max. Okay, I do not put in bracket here. Okay, this is what we want to create the data. So let's say let's also add 1. And why we want to add 1 is let's say, let's show you. We want to the line to start from, this will be, I hope this will be the minimum, and we don't want to start from here. We just want to start from probably here, the line to draw. So that's why I -1, and then also the maximum probably here, so we just added 1. I hope that makes sense. It makes sense. But now we want to create 100 number from this minimum up to this max, 100 numbers. This integrator will going to figure out those numbers, but the difference between one number to another will going to be equal for each. So 100, and this will be our x line. But for y line, we want to multiply m, our slope, with the x line, and then let's do some bracket here. You will going to multiply this one first, and then you will add it b after it's multiplied here. So this will be our slope, and this will be the continuous. And as you can see here, this will going to be all value, the area value, the x value, and the y value are depending on the x value, and these slopes and continuous. So now we successfully create our variable here. Now let's plot our data. So I'll just going to come here and copy and paste it, just this one, and I will do command and slash, I'm sorry, shift and tab, and we're going to take it back to the tab space. And then also we want to be area here, so we want to cut. Let me show you. This is what we have there, but now we want to add something here. So we can say we want to add the straight line. So now we are going to do that. So now we are going to use plot. That's what we're going to make a straight line. Okay, and we can just say, and then also let's change this one to area, no, x column. This will be the x, so with x, so yeah, we good. Yeah, this also work. Yeah, this price, this area. That's what we want. Yeah, area and price. Okay, now let's plot that straight line. So x line and just y line. I'm going to make straight line based on the x, the y, the x, the y based on that. Let me show you. You ready? I hope you are going to work. 3, 2, 1. Okay, you see this is what our data is shown here. This is how's our okay. You know what, let's change the color here. Color I don't know how to change the color, but I hope this is work. Yeah, okay, now it is good. You see, this is what we want to plot our data. This is what are predicting for 2000. It's predicting some price here, and for other two. I hope when I visualize the data that makes sense, and you can just I mean, if you see the data, you have many loss or incorrect predicting, as you can see here, because it just in fact this is just a very low model, but you can just predict some data by using linear regression model like this one. But look at that, this is what our model is predicting. Let's say here, as you can see, for 9,000, which means probably here it's predicting somewhere 0.6 here, or 6 million number. So this is how it's work. I hope this visualize makes very easy to understand it, and in the next part video I'm going to show you how can we calculate the loss, and then I will going to finish this project, and I will going to start making another project video. So I'll see you in the next part video. See you there. Goodbye.